Hi, my name's Scott Simpson, and today we'll be talking about covalent bonds. So covalent bonding occurs normally between two nonmetals, so something along the lines of H2 gas would be considered a covalent bond. So let's go back to our H2 molecule. So it would probably be helpful to go back and review Lewis structures. So what's happening here? Well, what happens in a covalent bond is there's overlap between orbitals and electrons are shared between atoms. So for example, we have our hydrogen molecule. Well, hydrogen only has the 1s orbital available to it, so that's the orbital that's shaped like a beach ball. So what ends up happening is you have these two orbitals and they overlap in the center. And what happens is that's a stabilizing interaction, and this lowers the energy of the molecule. So if you remember a Lewis structure, we have a single electron there, a single electron there, and it ends up being shared between two molecules. Now, let's talk about what is meant by a double bond, a triple bond, and a single bond. And then maybe we'll talk a little bit about hybridization. So, when we get up to larger atoms, let's say we're talking about carbon or nitrogen or oxygen, you can have double bonds and triple bonds. So what's happening in a double bond, in a triple bond? Well, we know that carbon not only has s orbitals, but it also has p orbitals. So if we think about two p orbitals that are oriented such that they're going to interact similar to our s orbitals that we saw for a hydrogen case, then we're going to get a single bond or sigma overlap. So the difference between a sigma bond and a pi bond is that in a sigma bond there is overlap in one region. In a pi bond, there's overlap in two regions, and if you care, a delta bond is overlap in 4 regions. So if we notice, we have our p orbitals, they're overlapping in one region, so this is considered a sigma bond. But what happens, how do we get to a pi bond or a double bond? Well, what actually has to happen is we have to have one sigma interaction and one pi interaction in order to get to a double bond. So, let's just image what a double bond, well, what a pi bond is. So we have two carbon atoms, and if we consider this either the py or the px orbital, we can look at a pz orbital. Let me erase this one up here. Where they're extending up and out. So something along the lines of this. And I over-exaggerate these quite a bit. And what happens is there's overlap between these two p orbitals. So we have one p orbital localized on, we'll call this carbon number 1, and one p orbital localized on carbon number 2. What happens is there's overlap in 2 regions. So one lobe of the P interacts with the top lobe of the P, and the bottom P interacts with the bottom lobe of the other P. So let's call this, we're going to denote these with signs which come from quantum. This will be a positive side of the lobe, and this will be a negative side of the lobe. And since they have the same sign, what ends up happening is there's constructive overlap, or it forms a bond. So this is considered a pi bond. So there's interaction between those two, and there's interaction between those two. So in order to get to a double bond, what you must have happen is you have to have one of these pi interactions, and we also have to have a sigma interaction. In order to get to a triple bond, we need one sigma and 2 pi's. So let's write this out. So in order to get, so type of bond, we're going to have number of sigma and number of pi. So if we have a single bond, we have a double bond, we have a triple bond. So for a single bond, we only have 1 sigma and we have 0 pi. For a double bond, we end up having 1 sigma and 1 pi. Then for a triple bond, we end up having 1 sigma and 2 pi. So I think we've covered enough about covalent bonds. My name's Scott Simpson. Thank you very much. And if you need any help with anything else, just let me know. Thanks.